Hello, everyone. I'm Minka. Thank you very much for having me here. So today I'm going to be talking about how we can build our Angular application for production, Angular 2 application. A couple of words about me. So I'm quite active in the open source community. A few of the projects that I'm working on are the Angular 2 style guides together with John Papa and Igor from the core team. Also Codealyzer, which is a tool which performs static code analysis over your projects in order to verify whether they're following the style guide or not. And also does provide some interesting information about if you have some unused CSS, for instance, or things like that. I'm also working on the Angular seed and used to contribute to the Angular core and the mobile toolkit. And I'm a GD. Also, the last year, I finished the book that I was working on for about 6 months called Switching to Angular 2. I had the privilege there to get technical review by Mishko Hevery, but it is not yet up to date with the latest Ng module changes, but we're working on the second edition. So this presentation, it is going to be based on a blog post that I published a while ago, how we can build our app for production. And we're going to go through a couple of steps. We're going to discuss some basic steps such as bundling, also minification. From minification, we're going to jump to tree shaking. After that, we're going to switch to ahead of time compilation. We're going to describe what AOT is and how actually it helps us to build faster applications. And we're going to finish our journey with compression. But before that, let's just build a very simple Hello World application in Angular 2. How many of you have actually used Angular 2? Okay, so a lot of you. Maybe it's not going to be super fun the first couple of slides. Here is an index.html file where we're including a couple of scripts, some polyfills like zone.js and reflect, and also our final bundle of our Hello World application that we're going to have by the end of the presentation. Our final bundle, it includes Angular as well as our logic. And this is the root element for our application, my app. Basically, our application is going to be rendered right here. And this element, it should be matched by the selector of the app component. The app component is the thing which is going to be the root element of the root component of our application. And as you can see, its template is super simple. It should render only a single text node called with content hello world. On top of that, we have our root application module, which has a single import, the browser module, and also a single declaration, which is also used for bootstrapping our app. And that's the app component. And since for the first couple of versions of our Hello World application, we're going to use just-in-time compilation, we're importing here the platform browser dynamic module. And we're invoking this imported function. And right after that, we're invoking the bootstrap module method with the app module, which is going to be a root module of our app. And that's great. We already have our Hello World application, but it's not ready for production. We need to bundle it in order to somehow increase the performance and the load time. And bundling, I bet all of you are familiar with it. It's just a standard practice which aims to reduce the number of requests that the browser needs to make in order to deliver the entire content of our app. And here is the example. This is our application in development mode. As you can see, we load hundreds of files. In this case, 123 files. And it's being loaded quite slow for about 3 seconds. However, after we bundle the app, we're going to be able to load the entire application for less than a second, and we need only a single request for the entire logic of the application, which in this case is in app.js. However, this is not optimized app, so we're going to get much better. And generally, bundling helps us have less requests, so we're just able to load our application much faster. And for bundling, we can use some tools which are into the wild for a couple of years now, such as Browserify. Browserify just needs an entry point, and it bundles everything which is referenced from within this entry point and all the transitive dependencies. And we are able to output everything, the entire application and all the different dependencies that it has into bundle.js. And well, we are kind of done. However, this way, we are introducing one very big and blocking request. It might not be blocking if we are using the async attribute of the script tag, but it's definitely big. And can you guess how big this request could be for a Hello World application? Just keep in mind that we have bundled everything, like the entire Angular source code, all the different commands, like almost the entire API doc, a lot of white space, like every single variable is with its original name. Can you guess how big the bundle is going to be? Like, any suggestions? Okay, yeah, it's not that big, but it's quite big. It's 1.4 megabytes. Yeah, it's a lot. So we are going to slightly change our goal now. We're going to try to build our Hello World application again, but we're going to try to build it with a minimal payload size, like minimal size. And the first and most obvious technique that we're going to use is, of course, minification and dead code elimination. And we're going to make a smooth transition to some more advanced techniques in a little bit. So minification and dead code elimination, we here have, for instance, mangling, which includes things like renaming variable names, also renaming property names. We have also compression, which includes dead code elimination, and also compressing property accesses. We're also able to get rid of some pure functions if we are not using the results of their invocation. So some tools for minification, they provide some pretty cool features. But we're going to focus on dead code elimination just for a little bit in order to be able to reach tree shaking. So with dead code elimination, we, for instance, can have the following snippet. We are logging the output of the answer function. So we're just going to invoke this function and output the result. And you can notice that in this function, we have defined a constant called expression, and expression will always have a value which is equals true. Right after that, we're checking whether expression has a truthy value and returning 42 if is that the case. Otherwise, we're returning 1.618, the golden ratio. And obviously, we can just drop the constant declaration because it's useless, and we can just replace it with its value instead. This is still great, but well, we can do much better. We can just drop the if statement itself because, well, obviously, we're always going to enter the if statements block. And we can drop the second return statement because that's basically dead code. We're never going to go there. And since our function now, it is a constant, we can just drop the entire function and just output 42. Usually this technique drops just small bits of our code because hopefully in production, like in our daily life, we're not writing that code like this one. However, if we invoke Uglify.js with some advanced compression options, and we get rid of all the entire API doc and like everything which is not necessarily going to be part of our final bundle, we're going to reduce our app dramatically. Do you have any suggestions how big our app is going to be now, like after minification? Just, yeah, give a shot. Yeah, that's pretty close. 524K, which is like, it's much better compared to the previous bundle. Like, it's much better. It's 3 times more, but it's still huge. And it's only a Hello World application. It is not supposed to be that big, right? And one of the problems behind our bundle being that big is that, well, we are trying to bundle CommonJS modules. And CommonJS modules, by definition, they are quite dynamic. But let's take a look at an example and see why. So here we have our entry point again, and this is the index.html, index.js file. And inside of this file, we are requiring lib.js. And by invoking require is going to return an object. And by using JavaScript property access, we're just getting the full property of this object. So this is quite dynamic. By definition, the JavaScript property access, it is very dynamic. And in lib.js, we're exporting 2 functions. We're exporting foo, which is used by index.js, and we're exporting it by setting a property again, JavaScript property, setting property. And we're also exporting bar. And as you can see, bar is not something that we're using in our final bundle. However, if we use browserify in order to build our app, we're going to have both functions, unfortunately. So in our final bundle that we just built, and with browserify, and after that minified with Uglify.js, we still have some dead code, which Uglify.js wasn't able to eliminate. But why is that? Well, As we mentioned, the CommonJS modules, they're quite dynamic. So we can do some very fancy module imports. In this case here, we are reading a file called name.txt. We're getting its content, like trimming it. And right after that, we're getting the export, which is named after the content of name.txt. So this is quite dynamic. This is super dynamic. And there is no way for a static code analyzer to be able to trace which pieces of code we are actually using, which exports we are actually using in our final, should be using in our final bundle. So yeah, there is no way to make something smarter with CommonJS, of course. However, there are the ECMAScript 2015 modules, and they're static to some extent, and they can be statically analyzed much easier. Let's take a look at a very simple example, just the same example, but with CommonJS modules instead. So we have our index.js file again, and we just import foo from the library. And inside of our library, we're exporting foo and bar. Notice that this time we're not using the JavaScript, like setting JavaScript property, like object, setting a property of an object. We're just exporting a statically resolvable identifiers here. So this export is always going to be called foo, and this is always going to be called bar. And we cannot just export something dynamically here. Same for the imports. We just import foo from the lib package. And a couple of cool things here are that the list of imports, the symbols that we import, it is always going to be fixed, and it is also going to include always statically resolvable identifiers. And on top of that, the path to the library, it should be static as well. So something like this, it is not allowed. So we cannot use template literals. We cannot use properties like JavaScript variables. We cannot use anything. We must use string literals. So this is invalid. And if we bundle our application with a bundler which understands ES 2015, we will be able to get something like that. So we will be able to just get the final bundle with the entire code eliminated, like that code eliminated. And this is thanks to the properties that the ES 2015 modules have. As we mentioned, the exports are always static. So we are exporting either some identifiers or the default export. And the imports are also static as well. So our strings, our paths are always string literals. And we are importing specific symbols. Or, of course, we can have wildcard import, which brings us to a case something like quite similar to the CommonJS one. So this is quite dynamic as well, and we cannot really tree shake it. Yeah, and this process of just dropping a new export, it is called tree shaking. That's all that tree shaking is. We're just dropping everything that we're not using, like all imports that we're not importing, or exports that we're actually not importing in our final application. There are quite a few tools that are going to help us with this. So we have, for instance, Rollup.js, and out of the box, it supports ES 2015 modules. There is also a CommonJS plugin, which allows us to perform some tree shaking over CommonJS as well, with a little bit more verbose configuration, unfortunately. We have Webpack 2, which does pretty good tree shaking, and Google Closure Compiler. Google Closure Compiler was around for a while, and it has partial support for ES 2015 modules. Unfortunately, it doesn't support export star right now. However, yeah, hopefully it is going to be inside Google Closure Compiler in the next couple of months. Now let's just use tree shaking. So we can use another more fancy bundler, and we can perform tree shaking and see how big our final application is going to be. If we use tree shaking with Rollup.js and provide the configuration from config.js, we can bundle all the ES 2015 modules into our final bundler, which is built bundle.es2015.js. Notice that Rollup, it works by default only with ES 2015 code. So the ES 2015 modules, they're not something that is supported by the browsers right now. So right after that, right after we bundle our app, we need to transpile it to JavaScript, to like ES5. in order to be able to use it in most modern browsers. In the end, we perform, again, like minification in order to remove all the useless comments in white space. And yeah, can you guess how big our bundle is going to be now? We did so much computer science. Like we did static code analysis, and we removed dead code with tree shaking. And before that, we had some dead code elimination with Uglify.js. Do you have any suggestions?
Yes.
300. Yeah, I was super disappointed when I saw that it's 500. Yeah, really, I thought that I'm doing something wrong because there's so much computer science going on here, and only 500, like 22K less. And even on the chart, it looks even worse. Yeah, the biggest problem here was that, yeah, we are not currently tree shaking templates at all. And how we are able to tree shake templates? They are just strings, right? And they're not JavaScript. So our bundler doesn't understand them at all. It just thinks of them as strings. And in order to get better understanding with what is going on, just how many directives do you see right here? Oh, 5. That's what? 6. I see only 2. Well, there is obviously ngIf, and we have route or link as well. But yeah, that's just guessing. We can't have much more, unfortunately. Of course, if we have components like this one, hero component, which matches all different div elements with class names which have hero, for instance. In this case, well, we have one more. So we have 3. And it is not quite obvious at build time which directives are used in which templates. This means that, well, at runtime, it's obvious because, well, we know everything that, like, we know the context into the component tree for each individual component. However, at build time, it's not completely obvious. And however, well, we can see that our application doesn't use any directives, right? We have only a single text node. We have nothing. Unfortunately, in our final bundle, we're going to have ngIf, we're going to have ng4, and much more other useless directives. Well, does this mean that we cannot truly tree shake our Angular applications? Because we have JavaScript, but we also have, we have TypeScript, but we also have some templates which are nothing that our bundler can understand. Sorry?
What is tree shaking?
Tree shaking, that's the technique for dead code elimination that we described in the previous section. Yeah, it basically involves only removing unused exports from other modules. Yeah, that's it. Unfortunately, with the Angular templates, we are not completely sure what exports from the other modules we are using because they are not JavaScript, they are TypeScript, they are strings. However, yeah, the Angular team, they provided a solution for this. And they introduced a tool called ngC, which is the Angular compiler. And ngC, it is a wrapper around TSC, the TypeScript compiler, which provides features specific to Angular. Basically, ngC, it receives templates and a context into which these templates are being used. And right after that, based on the context into which this template is being used, it produces JavaScript or TypeScript. Well, we're going to use the TypeScript emission of ngC in order to be more convenient. Just notice that for each HTML element, the ngC is going to generate a call to the renderer. And for instance, for this div on top, ngC is going to generate renderer.createElement div. So that's it, just the JavaScript representation of these templates. And if we have an Angular-specific component or directive like ngIf, what ngC is going to do is it is going to generate a code for importing this specific directive from the module where it is defined in. And right after that, it is going to invoke it. It is going to instantiate it. And well, this is basically a transpilation of our HTML templates, HTML-like templates, to JavaScript or TypeScript. And this is pretty cool. Notice that we have here the ES 2015 imports. This is the process of so-called compilation in Angular. And we can have a ahead-of-time compilation this way. So the compilation, it will happen both ways. It can happen runtime, or it can happen as part of our build process. if we don't perform compilation as part of our build process, and in this case, when the user goes to our application, the compilation needs to happen anyway. So when the user goes to our application, all the different templates, they're going to be compiled to JavaScript, but as runtime, like part of the user experience, which means that we're going to slow down the rendering a little bit. However, we can also build our application, like compile our templates as part of our build process. And in this case, this is going to be called ahead-of-time compilation. So we have just-in-time compilation and ahead-of-time compilation. Just-in-time happens inside of the user's browser, and ahead-of-time happens inside of our browser, inside of our part of our build process. The AOT brings a lot of benefits. For instance, as you saw, we are just generating JavaScript with ES 2015 imports, which means that we can truly tree-shake our templates now, so we can get rid of unused directives. Yeah?
So that 500K, is that from directives that it includes by default, or is that actual templates that you had in line?
Yeah, well, we have only a single template in our case. It's only hello world string. So by default, our final bundle is going to contain uses directives, things which we are not using, because the bundler, it will not be able to understand our template. Like, our template is not JavaScript, it is just HTML. So the bundler will not be able, like, it cannot guess by default, if we're not using ahead-of-time compilation, which directives and which components we are exactly using inside of these templates. So because of that, we need to pre-compile our templates to JavaScript, and then the bundler is going to understand exactly what is going on there, and we're going to be able to get rid of unused code. Yeah. OK. So that's exactly how we are able to perform tree shaking, thanks to the ahead-of-time compilation feature of Angular, which is pretty cool. But that's not the most, like, the coolest thing, of course. But we can also have much faster initial rendering. And that is super exciting because, well, we don't need to perform compilation when the user doesn't have to perform compilation. We don't have to compile the application once the user opens our app because, well, we performed compilation of the templates as part of our build process, right? And we're also able to get rid of the compiler from the final bundle. The compiler of Angular is just another Angular, just TypeScript module. And we're using this compiler as part of our build process. But since the user doesn't have to compile the templates runtime, we can just get rid of it. And that's it. So we will be able to reduce the bundle size a lot. And we can build our app with ngc just by using the tsconfig file, because as we mentioned, ngc is just a wrap around tsc, right? Right after that, we're performing the steps that we are already familiar with. We're transpiling our TypeScript application to JavaScript to ES 2015. Right after that, we are just bundling the ES 2015 code. We are transpiling the ES 2015 codes to JavaScript, to plain old JavaScript like ES5, for instance, ECMAScript 5. And we're just minifying the bundle. And so now when we see how big the bundle is, do you have any suggestions now? Third, how much?
Third.
Oh, we haven't reached this point yet, but that's still 210K. But yeah, we may reach this point eventually by the end of the presentation. So yeah, that's it. Comparing the individual builds that we had. This here is bundle only with Browserify. We have bundled app, bundled and minified app. We have bundled like tree-shake app and minified, which is like unfortunately the same as the previous build. And in the end, we have precompiled. So ahead of time, we take advantage of the ahead of time compilation. So it is precompiled, tree-shaked, bundled, and minified. And we were able to reduce the size about 2.5 times, which is still something. Now you might think, well, that's cool. So I have my 10 million lines of code Angular application, and I'm just going to use ahead of time compilation. And my final bundle is going to drop from 5 megabytes to like 1.5 megabytes. Well, that's not exactly the case. Actually, its size is going to increase a little bit, the bundle size of your app. And that's because all your HTML templates, they're going to be turned into TypeScript code, like TypeScript or JavaScript code. And the produced JavaScript code, it is going to be more compared to the HTML templates. So you're going to produce more code by applying ahead-of-time compilation. The rendering of your app is going to become much faster because you don't have to perform compilation as part runtime, but the app bundle is going to become bigger. Fortunately, the Angular team built the router with lazy loading in mind, so you can perform very transparent lazy loading and provide to the user only the code that the user actually uses. The last technique that we're going to finish with is compression. And compression, it is the most obvious technique that we didn't apply so far. Basically, compression in the context of HTTP is the following thing. We have our client and we have our server. When the client requests a resource, which is hosted onto the server, it is going to send a GET request and list all the supported compression algorithms. In this case, deflate and broadly. Right after that, the server, it is going to find the requested asset, and it is also going to take the intersection of compression algorithms, which are supported both by the client and the server, pick one of these algorithms, compress the asset, and right after that, return it back through the network to our client. And it is also going to mention which algorithm it used for compression. Once the client receives the compressed asset, it only needs to decompress it. And right after it is being decompressed, it can process it somehow. If it is JavaScript, it needs to go through like lexing, parsing, and interpretation. Some popular compression algorithms are deflate, which is very widely supported. Most likely you're already using it. We have, of course, also broadly, which has some similar runtime performance. However, it usually performs more dense compression, but it is not that widely supported yet. It is supported only by Chrome and Firefox at the moment, I think. We can apply compression with broadly because let's say that, well, the users of our Hello World application, most likely they're going to be developers, or we're not going to have users at all. So we can just use broadly in order to compress our final bundle, and we can verify that its size has been dramatically decreased. It's only 39K right now. And on the chart, it looks pretty cool. In other words, we were able to achieve 36 times smaller bundle by going through all these steps. But I'm pretty sure that we can do even better. So there is a tool called Google Closure Compiler. Maybe you're familiar with it. It is pretty mature tool already. And it was built in the days when Java was still popular and cool. So basically, Google Closure Compiler, it compiles JavaScript. It performs some advanced code optimization techniques and also some advanced dead code elimination techniques. However, it uses type annotations. And at the time when Google Closure Compiler was built, we didn't have TypeScript yet. So for providing type annotations, Google Closure Compiler is using JSDoc. And we can provide type annotations for our hero factory by saying in the JSDoc that we have a single parameter of type string called name, and we also have as return value something of type superhero. And based on these type annotations, Google Closure Compiler is able to make some pretty cool stuff and perform some pretty cool code optimizations, which are not only going to lead to smaller bundle, but also to code which has better performance. But as you can see, this here is this is not TypeScript. This is not something that we're usually writing. So in order to reuse Google Closure Compiler with TypeScript, the Angular team built a tool called Cycle. And what Cycle does is to transpile TypeScript code to Google Closure compatible annotations, JavaScript with Google Closure compatible annotations. As you can see in our TypeScript, we just had the exact same hero factory. Instead of providing the type annotations inline, like as JSDoc, we're providing them inline. And in the end, we just get JavaScript with JSDocs. That's it. So Tickle transpiles TypeScript to Clojure-compatible annotations in JavaScript. Since the process of applying Tickle in our project is not super trivial right now, we're not going to go through all the different steps. But I did some experiments, and it turns out that I was able to get even smaller bundle, only 32K. Well, this sounds pretty cool, but this is also a lot of tooling. So in our presentation so far, we used TSC, we used Browserify, we used Uglify.js, we used Rollup.js, we used NGC, we used Google Clojure compiler and Broadly, which is like a lot of stuff. And when I was writing my blog post and preparing the slides for the presentation, I thought about this overhead of tooling and connected it with something that I experienced a couple of months ago. So as Jules said, I'm originally from Europe, from Bulgaria. If you don't know where Bulgaria is, it's right there. Right there. And I decided to move to Bay Area, to California. The first thing that I experienced, of course, was that the rentals were 1,000% higher than Sofia. But that wasn't the worst thing, actually. Well, I'm from Bulgaria, so I didn't have any rental history, any credit history. I didn't have anything. And I had to find a place to live. Fortunately, that's the Silicon Valley. So in the end, I found a landlord who said, well, I know that you don't have any credit history and anything, but I Googled you and I saw that you're doing some stuff on GitHub. So you can take this place. Yeah, that's a real story, actually. And that's my studio. And of course, it came unfurnished. And well, I wanted to buy some furnitures, and I wanted to buy something that does everything, to be able to sleep on it, to work from it, to cook on it, everything. So I chose this multifunctional furniture. And well, in the end, that's kind of similar to Angular, because Angular aims to do everything. Well, in the end, with this multifunctional furniture, I just got a bunch of food. Yeah, and I'm not this kind of engineer that is going to assemble this thing. Like, I'm a software engineer. So in the end, I just said, well, screw it, I'm going to sleep on the floor. And yeah, that's how I spent about 2 months. However, in Angular, you don't have to sleep on the floor, definitely. With Angular, all the things that we went through, they are completely automated by Angular CLI. And there are also a bunch of seed projects out there which automate this build process for you. So you don't have to dig into all this insane tooling and different module loaders and different bundlers, different minifiers and transpilers. You just can use Angular CLI, and it provides pretty nice level of abstraction. Angular 2 Seed is another project that I'm working on for the last year and a half. I went through all the breaking changes since Alpha 14, I think. So yeah, you can just give a try to these tools. Here are a couple of resources that you can take a look at. For instance, the Angular Performance Checklist provides a couple of techniques for better runtime performance of your applications, improving the runtime performance, and also the network performance. So you can take a look at the article that this presentation is based on. The Angular Mobile Toolkit is something which is pretty cool too. It helps you to make your application even faster by using service workers. I worked on the app shell functionality of the Angular Mobile Toolkit. It was pretty fun. You can take a look at the Angular CLI and the Angular Seed. And I will really appreciate your feedback about the talk on this link here. And thank you very much for your attention. Yeah, if you have any questions about building Angular apps for production or Codalizer especially, I'm super excited about this. So yeah.
Quick question. Is there a good way of doing server-side rendering, rendering Angular to markup in a .NET environment? Like do a .NET server?
Yeah. I think I'm not sure completely sure if it is officially released, but I'm sure that the .NET team is collaborating with the Angular team on doing this. And since recently, Universal is now, it started as a community project initially. Patrick and Jeff built it a couple of months ago. Since recently the Angular team moved it, like officially started maintaining it, so it is even more stable now. And yeah, they're working with the ASP.NET team. So if it is not released now, it's going to be released pretty soon.
Do you know if they're going to backport it to prior to .NET Core? Because I saw there's some .NET Core stuff for this, but what about like .NET 4 or 5?
No, yeah, I'm not sure about this.
What was that previous URL
for the feedback?
Yeah.
Here it is. And do you have, yeah?
In your list of build tools, how important is the order that you run them in? Which is now a silly question that your last slide tells us we can do it all at once anyway. But,
yeah. Well, it's pretty important because like one artifact that is produced by the previous build step, it is used in the other. So it is like pretty strict pipeline. You need to go through ahead of time compilation first, and it is going to produce TypeScript. And right after that, you need to transpile eventually this TypeScript to ES 2015. Right after that, you need to take this 2015 code and bundle it with RowUp.js eventually. And in the end, you need to, well, it's not, we haven't reached the end yet. You need to transpile this to ES5, and right after that, perform some code, some kind of minification with Uglify. But that's only if you're not using lazy loading of modules. That's for producing a single bundle. It gets slightly more complicated. I think Angular CLI is doing pretty good stuff on this. It uses Webpack, so not RowUp.js for now, but it's like pretty reliable. It's pretty cool. And in the Angular seeds, we're using System.js as bundler and going through almost all, like the same set of steps. Yeah.
For somebody newer to Angular, are there any specific online resources?
Yeah. Okay. So the documentation is pretty good. Wardbell is doing a great job there. Also, Thoutram Pascal, he's doing a great job. I hope that I'm not going to miss anyone. But Victor Savkin, he's doing a great job there. I'm trying to blog from time to time. I don't know how good are these blog posts. You can take a look at them. Yeah, I think that's pretty much like the most reliable resources, I guess. Of course, there are some others that cannot come to mind.
So
yeah,
you got like 1.4 MB to 34K, and you mentioned that service worker can bring it to 0. So this load just it will never be anything. Like it will be always 0, right?
Well, after after the first vote.
Yes, my question is, service worker has its own way to implementation, but in Angular 2, is there something like with the tool we can just implement automatically during this process, the whole process which is they have shown? So is there something you have for Lego?
Okay. Yeah. So the service worker, it is going to decrease the load time of your app after the initial loading. Right after that, the Angular mobile toolkit, it provides pretty awesome service worker pluggable architecture. And inside with this architecture, you can just, so it is something like chain of responsibility to the design pattern. You have just different service worker plugins which are handling your requests just one by one. And one of these plugins, it's exactly for caching static assets. So all you need to do there is just to run one Webpack task. It is going to produce a manifest file, and you need to register your service worker. And it is going to do everything for you.
So how about if in the middle, if you have something which needs a consistent checkup, right? That needs not to be, we have to exclude kind of, right? Like socket or something, which needs to be constantly uploaded, and how we can figure out that to exclude in the middle.
Yeah.
So that portion doesn't.
Yeah. So this plugin for managing static assets, it is going to handle only the requests it is going to handle requests only to files which are mentioned into the manifest file. So you're building a manifest file, and there you're saying, well, I want to cache bundle.js only, for instance, and let's say zone.js. And once the service worker sees that you're requesting bundle.js, if this asset is already available into the cache and it haven't changed in the meantime, it is going to just take it from the cache and return it to the user. But it is not going to handle any other requests except this mentioned into the manifest file.
There is some kind of like memory limit for the service worker which can handle efficiently? Like if I have some kind of application which has a really big JS bundle,
Yeah.
everything cannot be like that optimized, but really big. So what is the limitation of the in terms of memory? How much it can handle? How much it can like?
Well, I've had problems with some very big bundles. I'm not sure if it is defined into the specification yet.
I have some
but
problem with that.
yeah.
I started using like 2 years ago Google Earth web version, and they abandoned that last year. They said we cannot support it because of Java and the fasting. So we started using the CZM.js to make the 3D version of artificial. It's pretty stable now. So that one, when we start using that, even if you use the service worker, the system, even the fastest system, after sometimes you open 3-4 instances, they start like dying, like CPU can like that. So the service worker is not handling that part, and that has at least like 200 JavaScript. And it's loading like every call that's loaded a lot of images from the server. So
yeah. Well, I guess you can also
that's why I asked that question, how much you can handle efficiently.
Well, it's not something Angular mobile toolkit specific. It's service worker specific, I guess. This is mostly concerning the Chrome teams, I guess, and the Firefox teams. You can always, using the mobile toolkit, just exclude these things and use the browser cache.
So,
and expires
when
headers.
JavaScript is so much like compressed, and we have to run time debugging, then that efficient works.
Well, you can have source maps and you can debug it. I usually prefer to not include source maps in my production bundles, but yeah, you can do that. Source maps provides a lot of flexibility and tooling on top. For instance, you can take a look at exactly what makes your application bigger. You can build a map of your entire bundle and see what percentage of it is taken by Angular, what percentage of it is taken by your application. So there are pretty cool tools with source maps. Yeah.
But you mentioned System.js. So if you're going to be bundling all this stuff or using Webpack or something, you don't need a module loader? Or did you ever mix those?
Well, yeah, you can mix them. Yeah, it depends still. If you are using lazy loading, you need a module loader. By default in Angular, it's System.js. If you bundle everything into a single file, you don't need module loader. You can have mixed approach, so you can have different bundles, and then you can just grab one of these bundles lazily by using a module loader. I'm using in the Angular seed project the System.js builder, which is different from the System.js module loader. It just bundles different dependencies into a single file.
We just started like looking at Webpack as an alternative to like.
Okay. Yeah, Webpack 2 is pretty cool.
Yeah, your recommendation?
Well, I guess Webpack is a good choice. With much less configuration, you can have great results.
So it sounds like it's AC.
Yeah, Webpack 2.
So where do you define like your code splits? Does Angular system?
Yeah, it's almost transparent for developers. Inside of your route config, you just need to provide a string instead of reference to the module that you want the router to load. And this way, since this is a string, it is not direct reference, the bundler, it is not going to include this module. And just the module loader will see this string, it will find the string, it contains path to the bundle, which you want to load asynchronously, and that's it. It's almost transparent for developers, and I believe that the Angular CLI makes it even more transparent, or at least it will.
So is Angular expecting people to switch to the Angular CLI like for most apps in production, or like are they supporting things like MGC with Webpack loaders, like all the other things like that?
Yeah, you can use basically you don't have to switch to Angular CLI if you don't like CLIs. There is also the Angular to Webpack starter by Angular class, the Angular seed project, or you can build everything like from scratch, which is going to take a while. It's kind of Well, it's not tricky because everything glues together pretty easily, but it's still like a lot of work that you don't have to do.
But does that include like NGC?
The Angular CLI or?
No, so like as far as the C project.
Yeah, the C project, yeah, it includes NGC.
And that's using Webpack?
No, it's using System.js right now. Most likely we're not going to switch to Webpack soon. We'll see.
If you are using C, is there any capability if you want to change one of the cases that you're using, like if you want to change from broadly or
Usually the compression is not something that the seed and the CLI takes care of. It's usually, for instance, Nginx or whatever server you're using. Both the seed, the seed for sure provides flexibility. So you can choose whether you want to use JIT or AOT. You can choose, but there is a lot of, the seed also provides multiple applications. So you can have multiple apps under a single instance of the seed, which share some code, like with shared code base. With the CLI, I think this is not supported, but there is also less configuration there since it uses Webpack. So both have pros and cons, I guess.
So the source maps, that allows you to use the source code when you're in the browser. Does source maps kind of survive all these transformations through the various tools?
Yeah, they can.
Like one example would be one step would convert the Angular template string into a series of JavaScript commands.
Yeah.
Is there a way to do a source map that shows it before it got transformed into JavaScript?
Yeah, I was discussing that. It's possible. Theoretically, it's completely possible, and I was thinking of doing something like that. But I was discussing this with a couple of guys from the Angular team, and they had their point. Well, they think that it's easier to debug JavaScript, because the code that the AOT provides generates, it's quite friendly to read, and it's much easier to debug this code compared to your HTML template.
You can't set a breakpoint.
Yeah, and you can go, and even if you're using JIT, you can still use, you can still debug this code, and it's super handy sometimes. Yes. Any other questions?
This pre-sheeting or data analysis, will it also analyze all
Yes. Yeah, by default, Angular it is distributed as ES 2015 modules.
If I'm probably a bad example, but let's say I don't want to use Angular, like 1.5. Angular was like
Yeah, it can exclude. It basically analyzes the entire dependency graph that you have, so it can exclude everything. Of course, some modules, which are some CommonJS modules, they're going to be harder for this. You can use CommonJS. You can use Rollup.js with the CommonJS module, and you can still get rid of these CommonJS modules, but that's not completely trivial in some cases. Yeah.
So AOT feels like a bit of a more special. You don't think there's been any research to just use like JavaScript or even like inspired side of code now earlier in the pipeline?
Well, AOT has some benefits. So what it does, so first of all, you have these declarative templates, and you're just writing some variation of HTML. Right after that, these templates, they get turned into an abstract representation, which is the AOT. And the Angular, and this is basically the parser. And at this point, some Angular tooling can eventually even optimize your templates somehow. So just like Google Closure Compiler optimizes your JavaScript AST.
So to prevent like static code analysis.
Yeah, and that's pretty awesome. It's possible right now. It's not happening, but it's completely possible, and I'm most likely sure that the Angular team are going to go in this direction at some point.
Would it make sense at all to do like write some on the template itself?
Yeah, I'm doing this in Codalyzer, and also the Angular core team is working on language services. So yeah, there are some great computer science guys there who are working on the language services. And Colorizer performs some static code analysis over these templates in order to find out, for instance, useless CSS that you have, or the AOT, since it generates TypeScript, you cannot bind to private properties of your components because, well, your AOT code, like your template, is going to be transpiled to a separate class, which uses your component as a context, so you cannot bind really to private properties. But yeah, there are tools which helps you to, yeah, your build can fail if you're doing this, or you can see it as a warning in your text editor right now with Colorizer. And the tooling is going to get, it's great now, but it is going to get even better. Yeah. Any other questions?
You seem to be like a mega tooling guy. What IDE do you use?
I'm using Vim with Steamux. Yeah.
So do you say that Angular CLI is going to stick with JS?
It is with Webpack. Webpack
It
2.
is Webpack.
Yeah.
Okay.
They recently did the transition, and I think they're pretty happy with it. They're even working together, like collaborating with the Webpack team in order to make it even better, both Webpack and the CLI. They're doing pretty good job there, and they're going, so doing good job there. I'm following the channel. Do you have any other questions? Something about service workers or bundling? Or... Yeah.
About service workers, I saw a recent project where they were doing code splitting, so they would have and they had a service worker almost load those in the background. So even before you like your app is already loaded to the next page.
Yeah. No, I haven't. Yeah, I've seen things like service worker used as mocking your backend for end-to-end tests and transpiling your TypeScript into a service worker and stuff like that. But I haven't seen that. You can do this with the Angular router, actually.
Okay.
Yeah, you can use. You have different prefetching strategies there.
So mode is okay for that is why the service worker has been invented, I guess. But what about the browser? That is like same efficiency we can expect from the service worker on the web, like on the other browsers. All of them are not supported, but
yeah, Chrome supports. Yeah, Chrome supports. And Firefox. Well, the service workers, since the service worker, they involve some, so they need to, they're invoking the JavaScript event loop at some point, because basically they're using the same event mechanism there. So they can slow down your requests with up to 100 milliseconds. But yeah, that's a price that you need to pay. And right after that, you can load your application for these 100 milliseconds, the entire app. So I think it's worth it. But they're still like a proxy inside of your browser. So they just slow down your application just a little bit. And of course, after that, they bring much better results, much better benchmarks, since you're getting everything from your local cache.
How much is the data side? Like that has two layers. One is all the assets, pages, layers, and everything that they store the data also in the local storage.
Yeah.
They store. So what should be the optimum limit to store the data?
Well, I'm not sure. I'm not even sure if this defined or it is browser specific.
It does on the documentation, and they have on the course on the recipe, and they're talking about that is how I knew that we can store the data, a lot of data on the. If they don't say the local storage is the optimal way of doing that, instead they use the.
Okay.
But I don't know how much is the limit. I want to store everything, but it won't work.
Yeah, yeah. With local storage, I've seen that people are even filling hard drives just by creating dynamically different subdomains. So, well, yeah, I'm not sure about the limits. Googled this too, but I think it's browser specific. Not sure how much, if it is defined somewhere.
A question about alternative ways of generating templates. So right now I'm using Angular 1, and with Angular 1, we tend to write our templates using Pub.
Okay.
Would that work with ahead of time compilation? Using a way of writing templates in Pub, bring it to a string that then be using TypeScript?
Yeah, should be able to. Yeah, you just need to perform the compilation of your Pub templates to HTML before you run the ahead of time compiler. And also JavaScript, like the Angular templates, they use slightly uncommon syntax for ngIf, for instance, with the star. And I'm not sure how many template engines support this. But generally, this should not be a problem. You can, since your styles, they can be the same way. They can be either inline or into the external files. You can use cells there without problems. Like you can use whatever you want to.
Okay, so you could do like the template. You could say kind of like Angular 1, like template URL.
Yeah.
File.
Yeah, exactly.
And that file could be JavaScript compiled version of a Pub template. Maybe
well,
it could be an HTML file.
Well, it should be an HTML file. Yes, okay. And right after it gets transpiled to JavaScript by the ahead of time compiler. Yes. So.
Thanks, Nico.
Yeah. Thank you.